Welcome back, grade 12s, to our video lessons on organic reactions. We are busy studying elimination reactions. We have done cracking, thermal cracking, and catalytic cracking. So this elimination reaction that I'm going to discuss in this video is called Dehydrohalogenation. And with dehydrohalogenation, you remove an halogen and an hydrogen from an haloalkane. So the removing of the halogen and the hydrogen from a haloalkane will form an alkene, and it will set a hydrogen atom free as well as an halogen atom. And there are two reaction conditions in this elimination reaction as well. So the products, except for the alkene, the other products, the byproducts, might be different in different situations. So we have thermal cracking of there are two conditions: thermal cracking, which involves a high temperature, and that will the products of thermal cracking would be the alkene and the hydrogen halide. The other cracking reaction is called reflux under strong heating conditions. Now, reflux is when you use a distillation tube and you allow the product that is formed to react again. Now, I understand that this is not that this concept is not discussed in the syllabus in detail, but reflux basically means under strong heating conditions. The other condition is that you use a strong concentrated base, and you have a choice of two. The one is sodium hydroxide or potassium hydroxide. They are the examples, or the very strong bases. Now, in this case, the product will be the alkene, and the hydroxide grabs the hydrogen that is eliminated from the haloalkane, so it forms water, and the potassium or the sodium will react and bond to the halogen. So you will form sodium, whatever, sodium halide or potassium halide, whatever the halogen is. So let's look at some examples of thermal cracking. Our example is, let me just look here, 2-bromo butane. No, wait, where are we? Chloroethane. Chloroethane. Using structural formula, we've got 2 carbons. Now, the chlorine could be on this first carbon or on the second carbon. It does not matter. It would be 1 chloroethane. And under thermal cracking, the products would be the bonds that are breaking is the chlorine will break off, and one of the hydrogens will break off from the second carbon to form a double bond between the 2 carbon atoms. And because the hydrogen and the chlorine is broken off under conditions of high temperatures, the hydrogen and the chlorine joins up to make hydrogen chloride. So the little triangle I'm using there represents the heat that is used. Only heat used, there are 2 products forming. Now, this is not the only example that we must be able to cope with. Let's look at 2-bromobutane. And its structural formula has it's got 4 carbons, and the bromine is on the second carbon. The rest of the bonds are between hydrogen and carbon atoms. So this is an haloalkane. Under thermal cracking conditions, now here the bromine is on the second carbon, so where will the hydrogen break off? Will it break off from the first carbon or from the third carbon? So what will happen here? Both is a possibility. Now, with the addition reactions, we had Markovnikov. With elimination reactions, we have Zaitsev. Now, Zaitsev discovered that the hydrogen breaks, obviously the halogen will break off. The hydrogen that would more likely break off is from the carbon with the least hydrogens. So this would mean that this third carbon in the chain will lose its hydrogen, so the double bond will form between the second and the third carbon. That is the most likely product that is formed, so it's called the major product. The major product is where the bromine breaks off and the hydrogen breaks off from the carbon with the least hydrogens. Obviously not the same atom as where the bromine is broken off, because you can't have 2 atoms being removed from the same carbon atom. So this is 2-butene, the most common, and because of thermal cracking, hydrogen bromide will form here. There is, though, the possibility that the hydrogen will break off from this first carbon, where the bromine breaks off from the second carbon, so that will form the double bond on the first carbon here. So this will be hydrogen, hydrogen, hydrogen. This is called the minor product. So 1-butene is the minor product. So Zaitsev's rule says that where we are going to remove the bromine, the most likely product will be the alkene that involves the removal of a hydrogen atom from the carbon with the less hydrogen atoms. So 2-butene is the major. It's also possible that the hydrogen can be removed from the adjacent carbon with 3 hydrogens, so that would be 1-butene. Right, another example. Now I haven't mentioned this, but this is an unsymmetrical haloalkane. So when we have an unsymmetrical haloalkane, you have 2 possible products. Let's look at, yes, that is the only one where we use the Zaitsev's rule. Let's look at another one. Let's look at 2-chloro Pentane. It will be a similar situation. So there would be 2 possible products in thermal cracking here. Oops, sorry. Sure. This is a saturated carbon. Haloalkane is saturated. So the chlorine will break off from the second carbon. And according to Zaitsev, the double bond will form between the second and the third carbon in this chain, as that carbon's got less hydrogens than the first carbon with its 3 hydrogens. So this is the major product. 2-pentene is major, and the minor product would be 1-pentene. Okay. This will bring me to the end of this video. In the next video we'll look at the last elimination reaction where we have dehydration. Oh, no. I still need to do the cracking under reflux conditions, so that will be in the next video. Thank you for watching.